So this question says that which of the following statements is true of a body moving in a straight line with uniform acceleration? The velocity of the body is, so we have some option. But before I look at the option, what do I know about an object moving in a straight line with uniform acceleration? An object going in a straight line with uniform acceleration means that the velocity of the object is increasing in equal amounts with equal time interval. That is the meaning of uniform acceleration. So an object moving with a uniform acceleration means that the velocity is increasing with equal amount at equal time interval. So now let's look at the option. Option A says that the velocity of the object is uniform. Actually, that is going to be incorrect because an object moving with a uniform velocity has no acceleration. What is acceleration? Acceleration is change in velocity over time. So uniform velocity means that final velocity is equal to initial velocity, which means that this formula is going to become final velocity minus final velocity because final velocity and initial velocity are the same over time. So we have 0 over time, and that is going to give us 0 meters per second square. So an object moving with uniform velocity has no acceleration. But the question says that this object is moving with uniform acceleration. So option A is wrong. Option B says that the velocity of the body must always be 0 when the body stops accelerating. Well, that is incorrect also. An object that is already moving with a uniform acceleration, when the object stops accelerating, the velocity cannot be equal to 0 because it has already attained a particular velocity. Alright, so option B will be incorrect. Option C says that will increase with time in the direction of the acceleration. I will go with this option. As I said before, the definition for uniform acceleration is that an object is moving with uniform acceleration if there's an increase in velocity with equal amount of time. So increase in velocity with equal amount of time, that's the definition for uniform acceleration. So an object moving with uniform acceleration has an increase in as its velocity to increase with time in the direction of the acceleration. Now option D says that is equal to the quotient of distance traveled by time. Well, this may look a little tempting because quotient of distance traveled by time gives velocity, but that is not the instantaneous velocity. Quotient of distance traveled by time is known as the average velocity. But the question did not say that we have to look for average velocity. The question asks us for velocity, which means the instantaneous velocity. So instantaneous velocity is not the quotient of distance traveled and time. It is the average velocity. Remember that formula for average velocity is total distance covered over total time taken. So this option D describes average velocity, not the velocity of the object at any instant of time or the instantaneous velocity. So option D is incorrect. Then option E says that velocity of the body is the product of distance and time. So velocity is product of distance and time. This formula is incorrect. So option E is also wrong, leaving option C as the only correct option.